Welcome back. In this lesson, we will understand how we can perform hyperparameter tuning using k-fold cross-validation. We will understand first what do we mean by cross-validation and what do we mean by validation dataset and why exactly we prefer the k-fold cross-validation. Okay, so let's start. You should know that we should never tune the hyperparameters for any machine learning model using the test data. Why? Because the ultimate goal of any machine learning algorithm is to perform well on unseen data, right? Because if we have a machine learning algorithm that like 100% accurate on the training data but 60% accurate on the test data, then it's no good, right? So the ultimate goal of any machine learning algorithm is to perform well on unseen data. And the fact that you are changing the hyperparameters of the algorithm based on how well it performed on the test data contradicts this idea, right? Because you are trying to change the hyperparameters based on how well we performed on the test data, right? We don't really want this. We want to tune the hyperparameters or change the hyperparameter based on a third dataset. So this is why we need a third dataset to validate or to experiment or to tune the hyperparameters on. And we call this new dataset the validation dataset, right? So the basic idea is to split the dataset into three separate sets: training, validation, and testing. Let's say 60-20-20 split. So we have 60% of the data is training, 20% of the data is validation, and 20% of the data is for testing. Okay? And we consider the validation set as our testing set when we are tuning the model. And after finding the best values, after finding the best combination of hyperparameters, we test on the test set. But we never tune our hyperparameter based on the test set or how well we performed on the test set. We change the hyperparameters based on how well we performed on the training set. Okay, and if we perform it really well, we get these hyperparameters and use them on the test set, and this is our final result. Okay, we have another thing called cross validation. Why? Because when you have a small data set, when you split the data into 60, 20, and 20, then you are left with a very small data set for validation and another very small data set for testing. You are not really using the whole data set for training, and you are not using the whole data set for testing or the whole data set for validation, right? So the idea of cross validation is when the data set is randomly split into k groups, and this is from where we came up with the name k-fold cross validation, right? We split it into k groups. One of the groups is used as the test set and the rest are used as the training set. The model is trained on the training set and scored on the test set. And then this process is repeated until each unique group has been used as a test set. And this method is much better than train, validate, test because we are not wasting any data, right? And this graph will make things more clear. This is from sklearn itself, right? You can go and read the documentation. So we have all data. We split this all data into training data and testing data. And now we want to find the best combination of hyperparameters. So let's say we will use 5-fold cross-validation with k equal 5. So here we have 5 folds. If we have 100 training samples, then we will have 20, 20, 20, 20, and 20, right? And they are not repeated. Each group is unique. The first split, we will use the first 20 for validation and the rest for training, and then we get the score. After that, we have the second split. We will use the second fold as the validation and the rest as training, and so on and so forth, until we finish 5 iterations, right? 5 splits. So we used the whole data set or the whole training data set for training, and we used the whole training data set for validation. And finally, we can do the final evaluation on the test data, right? After we find the best combination of hyperparameters. So now let's try to implement or see how we can use the k-fold cross-validation and how we can perform hyperparameter tuning using k-fold cross validation. So here we are, we have 4 splits. As you can see, n splits is equal to 4, and here we have the k-fold, right? This is the class inside sklearn, okay? And you can read the documentation here, k-folds cross validator. And then after that we have accuracy k, so this will keep track of the accuracy of each k, and I mean here by k, the k for k nearest neighbors, right? So the accuracy of how many neighbors we need. And the k values will be 1, 3, 5, 7, 9, 11 until we reach 29, right? So we have a list, and this list will contain values from 1 to 30 with a step of 2. Now we will loop over all the k values we have in this list, right, for k in k values, and as you can see here, we will loop over the splits, right? So for normalized x train fold index and normalized x validation fold index, n kf.split normalized x train. So this function, the split function from here, right, will return the indices for the training and the indices for the validation. So we will go to the training dataset, the original training dataset, and then we will fetch the values that we are going to use for this iteration for this fold, okay? The same for the Y train and the same for the validation indices. So as you can see here, normalized X train, but here we have the validation fold indices, and this will be our current testing data. Here I mean by X test, X validation, current X validation, okay? The same for Y validate. And then I am going to call the KNN algorithm from scratch we implemented, right, on the current fold, right, on the current training fold and the current testing fold or the current validation fold, okay? And I will be adding the accuracy scores, and then I will accumulate this accuracy, right, the accuracy scores that I'm calculating, and finally after I finish the 4 splits or the 5 splits based on how many splits we choose here, I will divide by the number of splits in order to get the average accuracy, okay? And after that I will append the accuracy score to the accuracy of the current k, okay? And as we said, k here represent k nearest neighbors, okay? So if I run this, it will take some time. And then if I run this line, this print line, the accuracy for each k value was, as we can see here, the accuracy of k equal 1 was 0.96, and the accuracy of 3 was 0.96, the accuracy of 5 was 0.96, right? But when we increase the k more than this, right, if we have k equal 9 for example, or if we have k equal 21, then the accuracy starts to decrease, right? So it's better to use k equal 3 or k equal 5 or k equal 1, okay? So if we run this and then run this, you will see that the best accuracy was 0.96, which corresponds to a value of k equal to 1. So this is the print message. And this print is very, very easy to do. And we can do this using the zip function, which will convert this into a tuple, and then we convert this tuple again into a list. So for each index in the list, we have a tuple. And this tuple, the first number in this tuple, right, or the first index in this tuple will correspond to the accuracy, and the second index will correspond to the current k value. And here we have numpy.max. We have a function in numpy called max, and this will return the maximum value, right? So I will give it a list and it will return the maximum value in this list or the maximum value in this numpy array, okay? And here we have argmax, okay? This will return the index of the max, right? So we give it also accuracy of k. This will return the argument max will return the index, so it will return the index, okay? So the index is 0. So we will go to the k values of this index, right, which is 1, okay? So this is how we print this message and print this message, okay? So by this we understand what do we mean exactly by the validation dataset and why we need it, okay? And what do we mean by the cross validation and how we can perform hyperparameter tuning using the cross-validation idea. Of course, in the next algorithms, we are not going to do something like this, because if we have more than one hyperparameter that we want to check, then we are going to need more than one loop, right? And it will take so much time to do so. So we are going to use some functions inside sklearn like grid search and random search. But I just wanted to show you, if you want to do it yourself, how you can do so. Okay? So in the next lesson, we will see the decision boundary using animation. The decision boundary that is used in KNN, we will see it using animation from Stanford University. Okay? So let's go to the next lesson.